Students and parents and students, thank you for tuning in. Appreciate you all supporting our education and the fact that the kids are allowed and empowered to go online at YouTube and actually review their notes. Appreciate it. Let's get going. These notes are on mineral identification. Seems very kind of high tech or scientific, but really it's just learning how to identify different types of minerals, or how scientists, people in labs who do this for a living, how they identify minerals physically by their physical properties. Here we go. Notes dash mineral identification. And like always, we always start off with a question. Now, what is the name of the scale used to measure the hardness of a mineral? Again, what is the name of the scale used to measure the hardness of a mineral? And of course, my students know the answer is the Mohs scale. The Mohs scale, named after a famous scientist. Here we go. Minerals, just overall, a natural non-living solid with a definite chemical structure. That's the definition we have. A mineral is a natural non-living solid with a definite chemical structure. Now, each kind of mineral has its own unique chemical structure, like I said in the definition, but most are identified by their physical properties. Now, every last mineral on the planet has its own crystal lattice or chemical structure, almost like if you wanted to compare it to human DNA. It's all different. However, scientists really identify minerals by their physical properties, what's on the outside. Physical properties of minerals, we're going to start off with hardness. Hardness, how hard is this mineral? Scientists use the Mohs scale to measure the hardness of a mineral. Now, a mineral's hardness refers to how difficult it is to scratch its surface. So that's how they measure the hardness. Can it scratch this mineral? Or can this mineral scratch its surface? They tell how hard the mineral is by a scratch test. Simple. Now, I'm going to look at the graph. We see the Mohs scales go from 1 to 10, and with degrees of hardness, it goes all the way up to 50. It depends on the graph that you look at. And we see that talc is the softest on the scale, on Mohs scale. However, of course, diamonds are the hardest mineral on the planet when we talk about a natural mineral. Luster, second way we use, or second way scientists measure the physical properties or identify minerals. Here we go. Luster. Luster is the appearance of a mineral in reflected light. In other words, how bright does it shine? We can use that to identify different minerals and different rocks. Next, we have streak, which measures the real color, the true color of a mineral. The streak is the mark a mineral makes when rubbed against an unglazed ceramic tile. And the reason we use unglazed ceramic tiles instead of just paper or concrete is we want it universal. Whenever you're doing an experiment, we got to make sure that we keep all the variables the same. So if I'm scratching it with this type of mineral, I need to be scratching it on the same surface, the same material that, say, a scientist in Europe or a scientist in South America. We all need to be using the same type material. So the streak is the mark a mineral makes when rubbed against an unglazed ceramic tile. Next, we have cleavage, and we're talking about minerals here. Many minerals tend to split smoothly along flat planes. That's cleavage. All right. Now, other minerals do not split, but they fracture, they break. It's rough. All right. In jagged, uneven pieces. The picture on the right, as you can see, very smooth size, like clean breaks. That's called cleavage when you're talking about minerals and rocks. All right, and on this side here, it's all jagged and rough, pretty much like any rock that you'll see outside. Any rock that we come across, most rocks actually fracture. They don't cleave. So you can identify different minerals by how they break. This is cleavage here on the left, and right here on the right, that's called fracture. Now, just sum things up. Now, minerals are made up of crystals. Every last mineral has a crystal lattice within, except obsidian. Obsidian is the only mineral, the only rock that does not have crystal because it comes from lava and the lava was close to the surface. Thus, it cooled real fast, it cooled real quick before the crystal lattice can form. That's why it's so shiny and also why it's so sharp. It really is odd, it's different, it's special. Obsidian, remember that. Now, a crystal, the definition, a regular repeating pattern in which particles of minerals are arranged. Most minerals are not found in pure form. Instead, they are mixed together in rocks. Again, minerals are made up of crystals. Really, rocks are made up of minerals. So if we want to break this down, you take crystals, they come together. A lot of crystals come together to make minerals. Crystals make up minerals. Then a lot of those minerals come together to make up rocks. It's almost like a stepping stone. Here we go. No pun intended with the stone. So we got crystals come together, they make minerals. Minerals come together, they make rocks. Thus, why we're studying the entire minerals and rock section. All right, it all goes together. Last but not least, most minerals are not found in pure form. Instead, they are mixed together in rocks. It's very rare when you go outside or you go mining and you find a mineral by itself. Got it? Most of the time they're inside rocks or in a form that we call ore. And then you have to mine and take it out of those rocks. Capiche? There we go. That concludes these sets of notes. For all my students who are making up this work, don't forget, you need to rewrite and summarize these notes. Again, excellent study skills, and that's really, really, really important to me. Make sure that you're studying this information. Rewrite and summarize. This is Mr. Guest. I'll see you all later. Thanks for tuning in.